We are on 2.7. So, okay. How do we factor these? We use the box. You stick in x squared and 36. Multiply those together. Are there factors of 36 that add to be 12, 6x, and 6x? And then we look in the top row, what do those share? An x. And if I pull out an x, what's left? X plus 6. And then if I take an x out of the first column, I get x plus 6. So the factors are x plus 6 and x plus 6. Or you could write it as x plus 6 to the second, because it's the same factor twice. All right. Okay, let's do this one. Same basic idea here. We draw the box. 49y squared and 4. Multiply those together, and we're going to get 196y squared. Are there factors of 196 that add to be negative 28? Well, you're just going to have to try numbers. So obviously 1 goes into 196. 2 goes in 98 times. 3 doesn't work. 4 and 49. 5, 6 don't work. 7 and 28. 9, 10, 11, 12 don't work, but 14 does. So it would be 14x, or negative 14x and negative 14x. What does the top row share? 7, 7y. Sorry. And if I pull out a 7 and a y, I get 7y minus 2. And if I pull out a 7y, then I get 7y minus 2. So once again, this has a duplicate factor. Okay. Ooh. I'm actually going to get rid of this one. Sorry. That shouldn't be in there. Okay. The other type of problem looks like this. So this is missing the middle term. So I'm going to write it just for representation purposes. Can you think of two numbers that multiply to be negative 9 and add to be 0? 3 and negative 3. So this would be x minus 3 and x plus 3. And we've seen these before. What do we call those? So this is a difference of perfect squares, and these are called conjugates. Because when you multiply them together, then they end up canceling each other out. Okay. All right. There are some more complicated versions of this. What's that going to be? Well, is this a difference of perfect squares? Is it a perfect square minus a perfect square? Yes. 2 times 2 minus 3x times 3x. So this would be 2 minus 3x and 2 plus 3x. And then the only other problem is this one that's written in two variables. Is that a difference of perfect squares? Yes. 3y times 3y minus 2z times 2z. 2z. So the factors would be 3y minus 2z and 3y plus 2z. What if this was a plus? Well, if they were both negative, would they turn into a 0? No. So it doesn't work. It has to be a subtraction. It must be a subtraction in order to work. Okay, I'm going to take out that one problem, but that's everything you need to know for 2.7.